Hi, I'm Scott Stewart. In this program, we're going to be talking about the concept of creating mats using a manual technique known as rotoscoping. Mats are used in a composite to put one image over another, and often we are not able to create these mats procedurally, so a rotoscope artist is required to come in and create the mats by hand. If you're creating a shot, say for example if you want to take me and put me into another plate, say of a sunset background, and you don't have the benefit of a blue screen, so you have no procedural way of creating a mat. And you don't have the benefit of a blue screen, so you have no procedural way of creating a mat. Then you need to have a roto artist come in and draw my outline, and essentially draw a mat by hand, my exact outline, moving over time in order to take me, element A, the foreground element, and put me over the background, which is the photographic plate B. It's important for a roto artist to understand how the mats are going to be used in the entire process of creating a composite, and why rotoscoping is necessary as opposed to procedural mat creation. So definitely check out the programs by Ron Brinkman on compositing concepts and Stu Mashewitz's tapes on procedural mat creation and keying. So you may have a question of why we can't figure out procedural ways of creating mats. Well, for instance, if we're shooting on location in the woods and we're supposed to have, say, for example, a dinosaur running through it, there's no way that you're going to be able to march these gigantic blue screens out there and be able to procedurally create mats. It's just not effective. It's not practical, and it won't really work very well. So the best approach is to have a roto artist do this by hand. Now, what does by hand mean? It means literally drawing each and every frame. Digital tools speed up this process, and we'll get into it and we'll discuss what those tools do and how they help you out. But it is very labor intensive, and it is very difficult. And we're going to go through some ways here in this program how to speed up the process and how to make the result stand up to your audience's scrutiny. Imagine if one morning you woke up and everything appeared to you in silhouette. Dogs, cars, buildings, everything was just a two-dimensional black and white shape. So the only thing that would differentiate one shape from the other was its outline, its two-dimensional outline. If you can imagine, if you can think of the world this way, then this is exactly how a rotoscope artist must see the world. It's important not to think three-dimensionally. That's a big leap that you have to go through in order to do this work. It seems like you wouldn't need to think about this stuff. It's subtle, but think of things in terms of two-dimensional shapes, only in terms of outlines, not in terms of how they're moving through space. You can think of mats being used in a few different ways. Conceptually speaking, you can either think of them as a cookie cutter or a stencil. For example, if you were putting me in front of a dinosaur, say it was running around behind me, then you would need to create a mat that was my exact outline, and you would use that mat to cut a hole, which is my shape, out of the dinosaur behind me. So essentially you would have a Scott-shaped hole cut out of the dinosaur. That would be the stencil approach. The overlay approach would be to think about it in terms of putting my shape, my exact outline, over the dinosaur. Okay, so that would be the overlay approach. You can think of them in any which way that makes most sense to you, but essentially it's either cutting a hole out of the background element or putting a foreground element over a background. That's how we make it look as if I am in front of a dinosaur. It's important to understand, when you go to the movies and you see computer graphic effects, for instance, like dinosaurs running through the woods, and you see people being chased by them and they're running away, computer-generated images, say like a dinosaur, 3D images, even 2D images, that are added to a shot are always on top of everything. That's how they look. If you were to look at those shots again of the dinosaur running through the campsite, or the Martians running through the field shooting at the soldiers, then if you were to look at those without the rotoscope artist's work in there, the Martians, even though they would appear to be moving dimensionally through the image, would actually be on top of everything, even though they should be behind things, other people, trees, bushes. So what you need is to create mats so that you can cut those shapes out of the dinosaur or Martian or spaceship or what have you. They're either cutting it out or you're taking those shapes and you're putting them on top. So once again, that's sort of how you're thinking about them in a few different ways. It's just important to understand it conceptually, what you're doing. It can be semi-abstract if you're not really familiar with this process. What is the process exactly? Well, think back to grade school. Remember when you were asked to trace, you got tracing paper and you were asked to trace an outline of say, for example, a person. How long would it take you? You'd sort of you'd work around, and it would take you a few minutes, and you would trace the outline exactly, and you'd be happy because you'd look at it and you'd say, wow, that looks like the outline of a person at the end of it. What rotoscoping is exactly that same process, but if you can imagine having to trace that person, say 90 slightly different versions of that person as that person was walking across a room. Well, that's essentially what you have to do to rotoscope a person walking across the room in a 3-second shot for broadcast television. 30 frames a second, 3 seconds, 90 frames long. The rotoscope camera was mounted a few feet above a flat workspace with the lens pointing straight down. The camera itself could operate either as a camera or a projector. Working on white animation paper held in place by registration pegs, the roto artist traced around elements in the image projected down from the camera. After each frame was drawn, the paper was replaced with a new one. This was repeated frame by frame until the element to be matted out had been traced on each frame of a shot. These traced images are then covered with clear animation cells and used as guides to fill with black ink. The cells are then photographed frame by frame, and the resultant film serves as a matte element in an optical composite. Thinking again of our person walking across the room example, what other than the time-intensive nature it would be to trace that outline, it makes it difficult to create a matte using rotoscoping. The important thing to remember is if that edge that you're tracing, say you were doing it on every single frame, you were drawing that outline with tracing paper, and if you were to play those back rapidly in succession, say at 30 frames per second, and watch it, the little differences that you created in the outline, not quite consistent from frame to frame, will cause the image, the outline itself, to chatter or shake or vibrate or crawl. And in the world of rotoscoping, this is called matte chatter, and this is your worst enemy. This is the big nightmare. This is what will keep you up, worrying that your mattes are chattering. This has kept me up. It's pretty pathetic, but it's true. The challenge of rotoscoping is to make the work invisible to the audience. You should not be able to see mattes chattering. You should not be able to see the edges of the elements that are placed from one image into another, me in front of the dinosaur, moving irregularly. I'm not moving very much here, so if my outline is starting to waver and chatter and there is something behind me, you will notice that this is an effect shot that is not done very well. There are two really subtle but very important things that make a composite look really good. That's color, and those are matte edges. If the color doesn't match, you're going to be able to tell that one thing is not properly in a plate. If the matte edges crawl, once again, you're going to be able to see that that element never really actually was in that plate. And that's a really important thing to understand when you're doing this stuff. Rotoscoping mattes is all about keeping things consistent, keeping the edges consistent. spline is a curve defined by a series of control points. The digital roto artist uses splines to trace the outline of an element and then refines that outline over the course of the entire shot. The result at the end, because the computer is able to remember what the spline looks like on any given frame you tell it to, is an outline that closely and accurately and smoothly defines the edge of an element that will then be composited into another shot. The spline outline can then be rendered into a black and white matte shape. Remember our example of the world in silhouette, of the cookie cutter or the overlay matte. The types of splines vary somewhat from tool to tool, but the main two kinds of splines are Bezier and natural bicubic. Bezier splines are the more common of the two. You'll find them in most tools. They allow the user to precisely define the tangent on the curve by manipulating a set of control handles attached at each control point. Natural bicubic splines differ from Bezier's in that the control points do not actually sit on the curve itself, and the control handles are implied. Let's look at how these two types of splines differ. The easiest way to do this is to create a shape using 4 control points, equidistant from each other. The Bezier spline will create a square. The natural bicubic spline will create a circle. It's important to remember that you can create any shape with either of these splines. Most tools are going to have Beziers. Only a few tools are going to have natural bicubic splines or B-splines. It's a matter really of personal preference. You talk to professional roto artists and they're going to tell you which splines they like using better. I find that it's nice to have both because certain shapes I prefer to use Beziers, for example, buildings or fences or sometimes cars, windows, shapes where it's more likely that I'll encounter hard edges, right angles, those kinds of shapes. And I will use B-splines or natural bicubic splines to do people or any organic shape. A garbage mat, as the name suggests, is used to isolate the image within the shot. For example, if you were creating a garbage mat for me, what you don't need to do is create an exact outline. That is an articulate. We'll talk about that in a second. A garbage mat just isolates me and separates me, say, from all of this garbage, we call, all of the camera rigging lights and the boom mics, so that you can then focus on that specific area, me here, for example, to do some more processing on. Generally, garbage mats are used in combination with keying techniques. And once again, I urge you to refer to Stu Mashewitz's program on procedural matte creation and keying techniques. An articulate matte describes the exact outline of an element. Think back of our silhouette example. It's the exact shape that you want to then put over another image. Often these two mats are called by other names you'll encounter, traveling mat or track mat. These are simply just referring to matte shapes that follow elements over time through the shot. Let's create a basic garbage mat using a Bezier spline. Before we begin, I'd like to mention one technical consideration before you start doing your roto. If you've shot your footage originated on interlaced video, it's important that you de-interlace first before you proceed to create your mats. Defining a spline shape is a simple process of placing enough control points around an element to describe its outline. Notice how the shape is only a loose outline around the element. By creating this loose mat, you will be able to isolate the element for further work. To adjust your spline shape, you can pull the points, or add more points, or pull a control point's handles. You can see here that adjusting the handles of a point affects the curvature of that particular region of the shape. You'll see here that this shape is closed. What do I mean by that? Most roto tools allow you to have both closed and open shapes. An example of an open shape would be a line. A closed shape would be a circle. Open shapes are rarely used for matte creation, and so for the sake of this discussion, we'll be talking exclusively about closed shapes. A consideration when creating a shape is to be careful that the spline does not overlap with itself. This will be bad for you. If the spline overlaps with itself, the region which is overlapping will invert when you render it out. So your mat will essentially cut a hole in itself. There is a good use to have another mat cut a hole in a mat, but we will talk about that more later. And you use two mats to do that. What is bad is to have a spline overlap with itself. That's not the way you want to cut holes in mats. Once we finish creating our mat shape, we will then animate that shape to follow the element over the course of the shot. A simple way of doing this is to set the shape on the first frame and then go to the last frame and adjust the spline so that it then is around the element on the last shape. The power of digital roto tools is that they are able to remember what the spline shape looked like on any given frame. The term that is used for this is the traditional animation term known as a keyframe. We set our keyframes on various different places in the shot in order to have the mat follow the element over the course of the shot. The computer will try to interpolate what the shape looks like in between the keyframes. What do I mean by interpolate? It will basically say, what does this shape look like as between this frame and this frame? How would that shape potentially look as it travels through time? In this current example, we set a keyframe on the first frame and on the last frame, and you can see how the spline shape is following the element over the course of the shot. Deciding which frames make the best keyframes is something that we will talk about later, but is very important to keep in mind. Creating an articulate mat is a much more time-consuming and exacting process than creating a garbage mat. You must lay down enough control points to exactly articulate the outline of the element you wish to mat out. Make sure you get the first frame right. The trick here is to be sure your spline stays right on the inner edge of the element. You got to look close to see where the pixels that represent the object to be matted are beginning to blend with the background. Make sure you only include the pixels that are 100% your element. That way you won't see any undesirable color along the edges of the element once it is composited over the new background. The thing that you're looking at closely here is you can see that the pixels of the element, as they anti-alias into the background, become semi-transparent, start to blend with the background. And what you want to do is you want to try to have, you want to try to keep your mat sort of semi-tight on the element so that it's on the inner edge, right? So that you don't have any of the blend pixels, the pixels that are part your element and part the background, included in your mat. And the reason that you want to do this is because in the composite, and you can refer to Ron Brinkman's program for more detail on this subject matter, but in the composite the mat is going to be most likely blurred and the edges of it are going to be treated in a way so that it looks like it's really in the shot. The element that's being matted out is really in the new background. What you're trying to do is you're trying to make sure that when, in the stencil example or the cookie cutter example or the overlay example, you're pulling something out of one shot and putting it in another. You want to make sure you're only pulling out the element and not any of its background. Once you've created an accurate outline around your element on your first frame, you're then ready to move to the last frame of the shot and adjust your spline shape. Remember, setting a keyframe. And make sure that the spline itself is exactly articulating the outline of the element you wish to mat. Now if you look at how the shape itself is interpolating in between these two keyframes, between the first and the last frame, you'll see that there's quite a lot of more work that needs to be done. The computer is not capable of figuring out what this shape looked like exactly. It's much more likely to be able to do this with a garbage mat, but with an articulate it's almost impossible that it's going to figure out exactly how this shape is moving. By now you're probably getting a sense of how difficult and exacting rotoscoping articulate mats can be. it is a difficult process, but there are a number of rules or techniques that you can put into action in your work that will definitely make the mats that you create much better and make the work go much faster. I like to refer to these as the roto rules. The first rule is to look for keyframes in movement. Remember we were talking about setting keyframes in the GMAT example and the first articulate example. We just set a keyframe on the first frame and on the last frame. But that's not the smartest way to go generally. When you're doing an articulate map, you want to sort of think the way a traditional animator would think about movement. Generally speaking, when an animator is trying to recreate realistic motion, he or she will look for keyframes and movement. Now, this is a bit different than what we were talking about before when we were talking about how a digital roto tool allows you to set keyframes. In the previous examples, we set the keyframe at the beginning frame, the first frame, and on the last frame. That it works for certain circumstances, but generally speaking, if you're doing creating a mat for, say, a person walking, the keyframes that you want to look for there are the extreme ranges of motion of that element. So you'll be looking at the frames where the arms and legs have swung out the farthest. You can take a look. In this example, if we set the keyframes for each footfall, you will see that the computer does a much, much better job of interpolating in between those keyframes, and it really saves us a lot of time. So you need to set your keyframes wisely. If we don't, we could take a look at an example where in this person walking, the keyframes are set sort of in between randomly. You'll notice that the interpolation is broken down. The computer hasn't done nearly as good as a job as it did the first time through when the keyframes were set properly. This will save you a lot of time, a lot of effort. So do make sure that you've set your keyframes properly. Look for the extreme ranges of motion. When I say extreme, say for example, if you're making a mat of me, I'm sitting here and I'm moving ever so slightly. This is very, very difficult to roto because you can see there's all sorts of subtleties in the way that I'm moving. It's very easy to imagine how you could just sort of leave the shape alone and it will, I will sort of swim within this mat because I am moving, but I'm moving very, very slowly. What are the keyframes in this? Well, you can go through with your digital roto tool and you can look at each frame. You can sort of step through them and you can see where is it that I've moved. Okay, so it's probably pretty subtle, but if I move over here a little bit like this, that's a keyframe, and if I move over here like this, that's a keyframe. And if I just sort of sway around, and you can get very, very exact and very minute with this, but it will actually save you quite a lot of time. By keyframing first, you let your roto tool do much of the work for you. You set your keyframes, and then you look for the frames in between those keyframes where the interpolation is working the least. That's when you then begin to refine your spline animation. And what you'll notice is that your shape then really starts to adhere to the motion of the object you're trying to mat out. What is the advantage of creating mats in using this process of keyframing first and then in-betweening as opposed to just rotoing straight ahead from frame one? The answer is consistency. You're gonna get a much more consistent and naturalistic motion to your mats. They're gonna adhere much more closely to the motion of the object you're trying to mat out. Also, because of the ability for your digital roto tool to interpolate in between keyframes, the roto tool is going to do a lot of the work for you, and that's always a good thing. The next rule is to use multiple shapes. When creating a mat for a complex shape, the important thing to do is to break down that element, that object, into its major geometric components. So, for example, if you're doing a person, you would probably want to create separate shapes for the head, the upper and lower arm, the torso, the legs. If that person has their hands out like this, then you would probably want to create separate shapes for this part of the hand. And the fingers. Even if it's a really close shot, you might even have separate shapes for the joints in the fingers. Now, why would you want to do this? Consistency is once again the answer. It may seem like more work at first, but it's going to save you a lot of time and frustration later. Let me show you why. Let's try animating with a single shape, a shot where a person is running. You can see where the arms go out from the body and swing out and then cross over and swing back. You're articulating that. So right, you've got the spline-based outline is articulating the arms, the hands, the torso, the legs, the feet. What do you do with the points in that spline, the control points on that spline, when the arms cross over the body and past it? You're going to have to take those control points and you're going to have to work them into the body shape, the torso shape itself. And then when the arm passes out, you're then going to need to find some points in the body that you had and pull them out and try to articulate around the arm. Now, are you going to remember what points were in the arms before they pass in the body and then pick the same ones when they move out of the body? Probably not. Now, it's not vitally important that each point correlate always throughout the entire shot with the same point on the element. The important thing there, though, is to try to keep things consistent. If you think it doesn't matter, think again. I guarantee you, the shape of the arm that entered the torso shape is going to be different than the arm shape that exits the torso shape. This will be noticeable, particularly in large elements moving slowly through frame. By drawing separate shapes for things like an arm, you will have to pull points less, and by pulling points I mean grabbing points and moving them along the spline, and thus be able to more easily maintain the integrity of those shapes over time, especially when they intersect with each other. Rule number 3 is use as few points as possible. Then try not to move them as individual points. Rather, move them in groups. Remember, you're making a shape that needs to be redrawn in upwards of 30 times a second. If you move the points on every single frame, they will chatter. It's going to happen. There's no question about it. Remember how earlier we described matte chatter as a roto artist's worst nightmare? Well, what is matte chatter? In digital roto, matte chatter comes from having a whole bunch of points moving irregularly from frame to frame. We can take a look at an example of that. They look like they're dancing about, okay? What we want to do is try to minimize the irregular motion of the points and try to have them follow a very sort of fluid and naturalistic motion of the element that's being matted. So one way to try to cut down on matte chatter is to make sure that you don't use more points than you need to. Make your start frame, that is the frame that you create your shape first on, the frame where the element that you were trying to mat out is at its most complex. So for example, if you were making a mat of a person, you would make your start frame the frame where, say for example, if the person had his or her hands out and away from their body, you would make that the start frame. You would look for the frame where, say for example, if you could see the hands clearly, to see whether the fingers are clearly visible as separate digits. That way you'll be sure to only use the minimum number of points necessary to accurately articulate the outline of the shape. Once you've set your points, try not to move them individually. Try to move them in ranges. It's important to do this, particularly after you've set a number of keyframes that are now in the process of in-betweening. By moving points in ranges, you will be able to keep the integrity of your shape over the entire frame range. Some roto tools allow you to add and subtract control points over the course of the shot. While having this ability can be helpful, it must be used with extreme caution. You got to be careful with this. The biggest thing to remember about changing the number of points in the middle of a shot is that they occur on all frames, meaning these changes are global. So, in other words, If you subtract a point you think you no longer need, it will be gone on all the other frames that you did need it on, okay? So therefore, it's generally best not to subtract points unless you're absolutely certain you didn't use it and to articulate anything else in the shot. So basically, you should try to avoid subtracting points unless you're just doing it on your start keyframe. This issue of subtracting points gets back to what we were just talking about in terms of creating your shape on the frame where it is its most complex. That way you won't need more points than absolutely necessary. That way you won't need to subtract them over the course of the shot. Just stick with the points that you start with and don't subtract them. Adding points is definitely much more forgiving than subtracting points, but it can still cause some problems for you in certain tools. Some tools will allow you to add points a little bit more liberally than other tools, which can cause you some problems. So to summarize the 3 roto rules, number 1 is look for keyframes and movement. Number 2 is use multiple shapes when articulating complex elements. And number 3 is use as few points as possible and try not to move them individually. Some rototools allow you to create negative shapes, which you use to cut holes in other shapes. Think, for example, of creating a circular shape, right? So you have a circle on the screen. What if you wanted to make that circle a donut? You could create a smaller circle, which would be a negative shape, and put that in the center of the larger circle, and what you would get would be a donut shape. It's important to, when thinking about negative shapes, they can be used and abused. It's better to articulate the presence of something as opposed to articulate the absence of something. Think, for example, if you had to create an articulate mat for a chain link fence, certainly it is better to articulate the presence of the fence than all of the individual holes that the chain link would create. A good example of how you would want to use negative shapes would be having to create an articulate mat for a car and you were able to see through its windows. You might want to have a group of shapes that articulate the body of the car, the presence of it, and then have separate group of shapes articulate the windows. That would essentially cut out the windows from the car mat. That would be a good way of using negative shapes. Even though you are rotoing the absence of something, you're rotoing the absence of something within the presence of something. Now, after you've created your articulate shapes and you've looked for keyframes and movement and you've used multiple shapes and you're trying to use as few points as possible and move them individually, and you look at your mat that you've created, you've rendered it out, or you look at your splines over time and you see that you've still got problems, the mats are chattering. This is going to happen if you haven't done this before and you're starting to learn how to do it. This is going to be a reality for you for a while. What you should be doing is cutting out the keyframes, removing them, and what that will do is you start to simplify your animation. Usually the beginner's mistake is to add more keyframes in order to try to correct chattering motion or jittering mats. That's actually the exact wrong thing to do. You should try to remove keyframes. Remember, what is mat chatter? So if things are shaking and vibrating and the edges are not moving in a naturalistic way, the best way to sort of get back to a place to start building up the animation again is to start blowing the keyframes away. Just start blowing them away. The frames that you set as your extreme positions, those are keyframes. And then the computer will interpolate in between those frames until you set another keyframe, which we call an in-between frame. But the computer thinks of them all the same as keyframes. You start to look for ways where your in-between frames, the frames that you're setting that are in between the keyframes, are causing you problems. And this really starts to happen when you start getting down to the nitty-gritty, going on every 4 frames or every 2 frames, or eventually if you set keyframes for each and every frame, it's going to be very likely you're going to have some kind of chatter. But This is sometimes quite necessary for you to have keyframes on each and every frame. So you're going to start to look for ways in which you can blow away the keyframes and start to rebuild your animation. After spending all this time talking about edges and how to exactly trace the outline of an object and make sure that it adheres to it in a naturalistic and consistent way, the thing we're going to face now is what happens when you get a shot and something's moving through it really quickly and all you see is motion blur, or for example, if you see willowy wispy hair that's backlit. How do I articulate an object that's edge is difficult at best to define? Well, there are a number of ways in which we can do this. It's an ugly process, but it's mostly a compromise. Let's start with motion blurred objects. If you have an element moving quickly through frame, you're very likely going to see some motion blur on its edges. What do you do about that? Now, some roto tools will actually create motion blur based on the movement of the spline. And that can be very, very, very helpful if it's done correctly. Some roto tools can't, so for the sake of this discussion, I will talk about it as if you weren't able to do it. What you should do is look for where the image is 100% the foreground element and not any of the background. If you look closely at a motion blurred frame, you're going to see your ball, for example, bouncing, and you're going to see the blur of the ball mixing in with the background. What we're going to do is we're going to cut that blur out. So what you want to do is you want to articulate the edge that is 100% opaque ball and not have anything that's mixing in with the background. Say, for example, you have an object that like a person's waving their arms. It's very likely that you're going to have the frame where their arms are down, that you're going to be able to see the arms with a hard edge. And then as they move them up really quickly, you're going to see a very motion blurred arm, where you're going to see very little arm. It's just going to be a fan of blur until it reaches the top of its arc, and then it's going to be solid, hard-edged object once again. What do you do with those in-between frames there? How do you articulate the arm? Well, what you should do is instead of trying to take the mat and pull it out to sort of match this big fan of blur, just leave it basically the arm shape and just sort of stick it right in the middle. That's going to be the best that you can do there. If it's a fan of blur, it's moving really fast, so you shouldn't be able to really see it. And in the composite, there are ways of treating the mat to try to recreate blur, and that's something that you can look at more in Ron Brinkman's tapes, Compositing Concepts. What do we do about hair? That's something that comes up quite often. If you have willowy, wispy hair, if you look at shots in close where you see a person's hair, particularly if it's backlit, you can see lots of willowy, wispy hair that would be a nightmare to try to articulate. You're not going to be able to do it. So what do? Us nasty roto artists, we give them a haircut. The object here is to just try to create a shape of the hair that is the sort of broad strokes. Just make something that looks consistent over time. It does not need to articulate every nook and cranny. Remember, you see what the element that's being mounted out looks like, but the audience has never seen it before. So you can sort of take some license there with it. Don't take too much. Just make it look real. Just make it look consistent. They're going to soften this mat anyway in the composite, and you'll be able to get a little bit of that willowy, wispy, sort of soft backlit hair edge in there, and this is the trick there. I'm a rotoscoper's dream, basically. Here, you can see this head right here. No hair, and I did this actually because of having to rotoscope so many people with hair. It just drove me crazy. In a perfect world for the rotoscope artist, there would be, everyone would basically look like this. They'd have no hair. Because it's a total pain. It's a total pain to actually have to roto. Now, what about semi-transparent objects? Well, you don't have to worry about that. Roto the object as best you can in terms of defining its edge, and then it will be in the composite that they will play with the opacity of the mat in order to try to create a semi-transparency. For the roto artist, motion track data is generally used to stick a mat into a shot. Say, for example, you have a shot where there is quite a lot of camera shake. That camera shake, that high frequency motion in that shot will make your life as a roto artist much, much more difficult because it's adding all that sort of high frequency motion on top of the motion of the object that you want to mat out. So another option there is to stabilize the shot first using motion tracking. In other words, remove all that high frequency motion of the camera, then do your roto on a stabilized version of that plate. So now you don't have any of the camera motion, you just have the motion of the element that you're trying to mat out. Then what you probably need to do is then reintroduce the camera's motion to the mat that you've now created. When do you use motion tracking? How do you know? Well, it's really case-by-case basis. It will work for you sometimes. It will not work for you other times, and sometimes you will try it and find that it's not helping you out. Basically, the reason why we try to do it is because anything that we can do to speed up the process, to proceduralize as much as we can, is definitely tried. So the important thing to remember in your quest as a rotoscope artist to create the perfect mat is that you may very well need to use any number, if not all of these techniques when creating your mat for your shot. For example, you could have an element in front of a blue screen with a semi-shaky camera. So you might have to stabilize this shot first, create a garbage mat around this element to isolate it, then you pull your extraction within that garbage mat. Perhaps there are wires suspending this element. You might need to do articulate roto in order to articulate the edge of the element and separate it from where it is intersecting with the wires. You might need to do some hand painting to clean up the extraction. In other words, you might need to use a lot of different techniques, and it's important for you to understand how your mat is going to be used in the entire process of doing the composite. So once again, I urge you to take a look at the other programs, Ron Brinkman's Compositing Concepts 1 and 2, and Stu Mashowitz's procedural mat creation and keying techniques, and motion tracking. So I hope you found this program informative. If you need more information, check out our website where you can email us directly any questions that you have. Happy rotoing.